Hello everyone, uh, welcome back to another video in EDC series. Today we are gonna learn about energy gap, and this energy gap is also uh, very useful to draw the. We will also draw the energy band diagrams as well for all for all semiconductors, metals, and insulators as well. And before drawing these energy band diagrams, we will understand what is this energy gap and what are these energy levels and all. So first, we will let us take one material, whether it may be a metal or a semiconductor or any material, and the electrons in these materials will either have a covalent bond or an ionic bond or a metallic bond. So the material may contain any of these type of bond. So if I am having specific bond, then I will have a specific energy state for these electrons here. So those type of electrons, the energy gap will contain those type of states, energy states here. So what are the energy states that I'm having is one is conduction band and one is valence band, and these are the energy bands that I'm having, and my electrons may stay in any one of these bands. Either it may stay in valence band or it may stay in energy conduction band. So we will represent this one as EV and this one as EC. So we will understand what is EC and what is EV. So let us understand here. In valence band, we will have in valence band we will have the electrons that are in the outermost cell of the electron. So we know you may have studied in chemistry. If you are nucleus, we will have cells, and the electrons that are consisting this outermost cell are known as valence electrons, and these electrons will be resided in valence band. So we will not have only one energy level here. We will have different energy states, and that is why we will call them as energy band. So this is a valence band. We will have different levels of valence electrons. So what is this EV? EV is does not signify the valence band. It signifies the energy level of outermost cell. It will outermost cell electron energy. EV represents the outermost cell electron energy. So EC represents the energy level of conduction band. So let us take we will in valence band we will have some electrons here. We are having some electrons. So these electrons, they will have a bond formed here. At normal t is equal to 0, they are attached to nucleus, and they are highly attracted to nucleus. So if I want to break that covalent bond, then I need to give some external electric field, which will drive these electrons to free itself, and then it will come up to conduction band. So as I've said, the electrons can either be in valence band or conduction band. There will be no electrons present in between these states. So first, I will say what is EV and what is EC. EV is the highest energy of valence band, and EC is lowest energy of conduction band. So here I've said what are the electrons that will be present in valence band. Now let us understand what are the electrons that are present in conduction band. So uh, if I am applying some external electric field, my electrons will break their bonds from the outermost cell of those atoms, and they will start moving to conduction band. So what we will have free electrons. So those electrons which are freed from their covalent bonds will come into conduction band. So in conduction bands we will have free electrons. So conduction band contains free electrons. So the energy required for that electron to break its covalent bond and reach to conduction band, and that is the difference between EC and EV is my energy gap. I think you understood what is the energy gap. The energy that an electron is required to break its bond from the outermost shell of the electron and then to the conduction band or and to become a free electron, then that energy is known as energy gap. So I can write Eg, energy gap is represented by Eg is equal to Ec minus Ev. So I've already said that there will be no electrons present in this gap. So why you may understand after breaking this covalent bond, this may become my electron may may stay at this E2 level, and at that time also my electron is free. But understand it clearly that there is no energy state for an electron to stay here. Uh, there is no energy state here. So this part is known as this gap is known as forbidden gap. There will be no electron. There will be no energy state for electron to stay in this region. So that is why we will call it as forbidden gap here. This is forbidden gap. There will be no energy state here. So what we can understand here, if my if to free an electron, then I need Eg to free an electron. We must require minimum energy, minimum energy of minimum energy equal to Eg. So we are considering the worst case here. Worst case means let us assume my outermost electron is he is here. So and if I want to read the conduction band and here, then the energy required for these electrons to come up to the first level of conduction band, and that will be the Eg. So let us understand what will happen in semiconductors here. So in semiconductors, let us take example for the energy gap of semiconductors. Let us take uh, silicon and germanium. Silicon and germanium, and we will take at T is equal to 0 Kelvin and at T is equal to 300 Kelvin. So here what I'm having is the value of the energy gap is 1.21 electron volt, and for T is equal to 300 it is 1.1 electron, and for germanium it is 0.7, or you can get 0.78, and here it is 0.72. So these are the energy gaps for these different types of semiconductors. So as we can observe here, uh, from these two, if I am increasing temperature, then my Eg is being reduced, the energy gap is reduced. Increase in temperature decreases the energy gap. So if my temperature is increased, my Eg is reduced in semiconductor. So let us observe what we can do at T is equal to 0. What is happening at T is equal to 0 Kelvin? There I mean, if you are not providing any external I mean, you are not having any thermal temperature which will make electrons to break the covalent bond, then there will be no covalent bond is breaked. Right. So no electrons will get excited to conduction band. So there will be no free electrons formed at T is equal to 0 Kelvin. Therefore, semiconductor behaves as insulator. Now at T is equal to 300 Kelvin, what will happen? If I am having my thermal yesterday in previous and about thermal voltage. So after if I am applying some at room, if I am keeping my material at room temperature, and that will become 300 Kelvin, then there will be a and there will be some and my electrons will tend to break their covalent bonds and they will try to come up to conduction band. So what will happen here? There will be breakage of covalent bond, breakage of covalent bonds. So my electrons and holes, both there will be a charge generated, charge carriers will be generated, and they will carry current. They will go from valence band to conduction band, so hence they act as conductors at T is equal to 300 Kelvin. So this is the energy gap of semiconductors. So now let us understand the energy gap in metals as well. So in metals, EV and EC both will coincide each other at T is equal to 0 Kelvin and at T is equal to 300 Kelvin. And at T is equal to 300 Kelvin, what will happen? EV and EC, and this will be my conduction band, and this will be my valence band. Right. So in metals, at T is equal to 0, there will be the EV and EC said even at T is equal to 0, my electrons and will easily travel to conduction band. Even though if I increase temperature, this band conduction band will come down, so there will be high. I mean, the free electrons will be easily formed, and charge carriers will easily go from valence band to conduction band. So here, even though if it is at T is equal to 0 or T is equal to 300 Kelvin, my temperature is not making an effect. So what we can write in metals, electrons concentration is independent of temperature. Even though at 0 Kelvin and at 300 Kelvin and T is equal to 0 Kelvin, at both the temperatures I am having my charge carriers flowing from valence band to conduction band, independent to temperature. So what we can write, as temperature is increasing, the valence band and conduction band overlap each other, and this overlapping increases. You can understand, you can see here, if I'm increasing my temperature more than 300 Kelvin, this valence band will go upwards and this conduction band will be coming uh, downward. So my conductivity further increases in metals. So now let us understand the energy gap in insulators. Here we will have EC here, and here I am having EV. And insulators, EC and EV is very high. Even if you apply if you take at T is equal to 0 Kelvin or T is equal to 300 Kelvin, the forbidden gap will not come close. So that my charge carriers will not flow from valence band to conduction band. So here EG is very high, and typically we typical value will be 5 electron volts to 15 electron volts. So if this value 5 electron and 15 electron volt is very much high in semiconductors. So what, even though if you apply high energy, high temperature, then the energy gap will not is so high that at high temperature also this will not come close. So so though my outermost electrons will not travel to conduction band, hence there will be no flow of electrons, and this is why bad conductors of electricity. Since there is no flow of current, then how will it generate uh, this, these electrons present in the valence band will never will be converted into free electrons. So we know that the current is formed through free electrons. If there is no formation of free electrons, there is no movement of free electrons from A to B, then there will be no current generation. So this energy gap is very high in insulators. So this is the energy gap in the semiconductors, metals, and insulators as well. We have understood what are valence band and what are conduction band, and what is the gap between the EC and EV. So why we have also understood that why there will be no energy state between the EC state. So I think you understood everything about energy gap. So that's all for this video. Thank you.